In my projects, when you're trying to combine two plastic parts together and have them like actually be secure, there's a couple different ways of doing it that I've seen and that I've tried, and I'm gonna talk through the couple of different methods, right? So the first one is a threaded insert, also called a neural nut. Basically, um, you take a soldering iron. You have to buy like a special tip for the soldering iron, and there are these brass inserts, right? And the soldering iron tip is like perfectly sized to fit within the threaded insert, and you like melt it into the plastic. And the threaded insert has these like little barbs that you can see that sort of like grip onto the plastic as the plastic cools, so they like really get locked in there. And the point of this is so that you can run fasteners through this, and now you have like actual metal threads in your plastic that you could put fasteners through to connect your parts together. And the really good advantage of this is great for like if you know you have a part that you're going to be taking apart and putting back together a bunch of times because the threads won't wear out. The difference between this and like thread forming screws is that thread forming screws create plastic threads that will wear out over time, so you have to be careful with them. So just a little bit about how they work. You take the soldering iron, you press it in, but you have to undersize the hole that you're using. And I just Googled like hole prep for heated threaded insert 3D printed part, and I came up with this little chart right here. So for instance, for my turret project, I'm using for my turret project I use a bunch of M4 screws, and for M4 it'll tell you that the hole diameter for an M4 screw for the threaded insert is 5.6. So the diameter of the threaded insert is a little undersized. So as you heat form it in, the barbs like really grip into the plastic and bite into it. So that's option one. This is like I if I know I'm gonna like reprint something over and over again, I won't use these because not that they're like super expensive, but like why waste this when I know I'm gonna be like printing out new versions. If I am going to be printing out new versions, I'll use this method, which is thread forming screws. So normally threads on a fastener are cut at an angle like such that they just like mesh with their corresponding threads. But these are cut at like such a wide angle that they like create threads as they're forming into the plastic. So if you imagine that this black and red thing like is your fastener, if you just look at it from like one plane in like a section view or whatever, and like this is your part, and you have this like hole in your part, right? And the fastener is supposed to go through. So if you pretend that this is your thread forming screw, as this goes down, right? As this comes down, it's going to start biting into the plastic, and it's going to create threads on both sides. So long as you don't like over torque the fastener too much, it's going to bite into the plastic and create threads within the plastic that the fastener can like mesh with. And I use these all the time. Like they're so great. You can get like a big pack of them from McMaster, and I'll show you how to do that in a sec. Like I have a pack of like 50 of them, and it was like a couple dollars, and I use it for like all my projects. And I'll show you how the McMaster thing in a second. But so this is the last thing, and this is called like, whoops. This is a an embedded square nut that I've seen a lot. So a square nut is just like a metal nut that is square, and the inside has threads that like can thread onto a bolt. So pretend that like this is your nut, right? You design your part so that like a nut, the square nut can just slide into your part, but the sliding in part of your part, or sorry, the clearance for the hole that the square nut slides into is super tight. So it's like gripping onto the square nut, so it can't really go anywhere. So you like create a really tight friction fit between the square nut and the plastic, and it just slides in. You might need like pliers or maybe a hammer to like really get it in there. And then on the other end, it's like supported with like another wall of plastic to like trap it in. But then you can take your bolts and have it, bring to front. Take your bolts, and now you have threads that engage with your fastener. And it's just another alternative. But once again, like I wouldn't use this method if I know I may have to reprint the part because you're just like wasting hardware. If I know I'm gonna reprint the part and I know it's not perfect yet, I'll use thread forming screws because I could still take the thread forming screw out and throw away or not use the plastic anymore, but keep my thread forming screw for future prints that I'll use. So now I'll show you how to do, so it has, McMaster-Carr has a great add-on with SolidWorks. So basically, let's say we needed a thread forming screw, and instead of these plastic fasteners that we're using, I wanted to use metal hardware. So the way that you get the add-on, so I'm just going to Google McMaster SolidWorks add-on, and you click this, you download this. You might have to restart SolidWorks, but if you don't see your add-ins, you go to Tools, and then you go to the bottom, Add-ins, and you just make sure that McMaster-Carr add-in is checked. And then once that's checked, you'll see McMaster-Carr on the right side in like your assembly part. And then here's the cool part. You could just go like, I could type in thread forming screw. I use M4 fasteners, so you could type in M4. If you need a specific length, you could filter by that. Let's say we need it to be 20 millimeters in length. And then they give you a bunch of different options, like different heads. Do you want it to be rounded, hex, flat? You could like filter by whatever you want. And then the really cool part is, let's say you pick out the fastener that you want. If you click like the part number, you could do add to assembly, and they have like built-in SolidWorks files already for you. So then you just save and insert part. And now you have exactly the part in your SolidWorks assembly. And then if you wanted to, the add-in will keep like a bill of materials for you. And then once you're done with your project and you're ready to like order the parts to put your project together, you just preview order and then you purchase it. Another thing to consider if you're going to do this for your own projects is the threads, because there's so many like faces and parts to it, like create or use up a lot of memory. So if I do that, if I use fasteners from McMaster-Carr, I'll roll it back and like disable or suppress the threads to basically save my computer like processing power. But that's it. Those are like the few ways that I'll like connect parts together. But that's just like a little FYI. We're not going to do that for this project because I'm trying to save you guys some money so you don't have to buy extra hardware. But obviously this is a scenario where like plastic hardware isn't needed. So yeah, see you in the next part.